So we're at the part of the lesson where we are given an equation that is not in factored form. So the first thing we have to do is get it in factored form so that we can sketch it, so that we can find the solution area for the inequality. So what you should see is a quadratic, and we're going to look at two of these, and then you're going to try one of your own. But in any case, you always want to make sure that this has, it ends with 0. And this one ends with negative 35. So you need to bring the 35 back over with the other part of the polynomial so you get it in standard form. So I'm going to move that 35 over and get it in ax squared plus bx plus c format. And this is greater than or equal to 0. Okay, so once you have it equal to 0, then what you're going to do is you're going to factor it. You can do quadratic formula. You could do rational roots theorem. It doesn't really matter. I'm pretty good at factoring, and I really think you guys would benefit from watching the factoring a couple more times. So I'm going to go ahead and factor this. If I'm going to do this one, I'm going to make an x. A times c goes on top, b goes on the bottom. A times c, 1 times 35 is a positive 35. B is positive 12. So I'm looking for factors of 35. I think you can see where this is going because 35 is pretty limited. It's 1 and 35 and 5 times 7. And we're looking for the factors that add up to positive 12. So that would be 5 and 7. When we put the 5 and the 7 in, they have the same sign because they have to multiply to give you a positive, and to get a positive 12, they both have to be positive. So you should have x plus 5 and x plus 7 as your factors. So back over here, I am writing my factors down. Now, if you're not good at factoring and you have a quadratic, please feel free to use quadratic formula. Just be careful with it. If you want to use synthetic division and rational roots theorem, have at it. There's a ton of ways, or a ton of different strategies that we've taught you to get this far. You choose what method works best for you. Now that it's factored, we're back to where we were before we started this problem. So I'm going to get my x equals negative 5 and my x equals negative 7. Okay, so those are my roots. Those are the two numbers that I need. The other thing is I need my y-intercept. My y-intercept in this case is easier to find without plugging 0 in. It's just the constant. And the constant when the polynomial is equal to 0 is positive 35. So it's just 0, 35. So I've got a single root here, a single root here, and a y-intercept here. I'm ready to sketch. All right, so I made my scale. A couple things you need to notice. First of all, I have a negative 5 and a negative 7. So I just, made some marks on my x-axis to get there. My y-intercept is positive 35, so I kind of cranked it way up top because I know that it's going to be a struggle getting from my negative 5 up to my 35. So it's going to be steep. The next thing I need to do is just look at shape. This is a quadratic because the degree is 2, which means that it's going to start up, end up, because my quadratic is positive. And the last thing we need to focus on is the fact that this right here is a greater than or equal to 0. So I'm looking for all y values that are greater than 0 or equal to. Because there's an equals, well, that means we're going to have solid dots on our x-axis. So I'm going to have a solid at negative 5. I'm going to have a solid at negative 7. There's no bounces. There's no turns, quick turns, because of the fact that these are just single roots. 35's up top. I have to start up and end up, which means this is sounds crazy, but that's kind of like what I'm visualizing. I'm not sure where the actual vertex is, and right now I'm not really concerned about that. I'm looking for the inequality piece. So I just need to know that this is the part that dips under. Okay, now what I need though is where are the y values greater than 0? So where is this thing above the x-axis? And if you look at the sketch, everything that's above the x-axis is everything from -5 and up, which means that on the x-axis from -5 and beyond, so that's all shaded. And then everything from -infinity to -7, that's where the x-axis is shaded, because these are the x values that produce y's that are bigger than 0. This x value makes this y bigger than 0. So when we're doing solutions, remember, our interval notation is about the x values, not the y values. All right, we want to know what x's make this happen. So I have 2 separate regions or sections, so that means that we're going to need a union as part of our solution. This is a -infinity, so you use a parenthesis, and a -7, and we use a bracket. And the reason why we're using a bracket is because it's a solid, because it equals. Then we're going to union, and we're going to do the other part, and the other part is from -5 to +infinity. And again, we're using a bracket because that -5 is a solid dot, and infinity is always a parenthesis. So this is your final answer for number 13.